Hi, CP Algebra 1, Stirrup here. So we're going to play around with line of best fit and putting data into a graph. Okay, so I gathered some data from a menu of a restaurant, and it shows that of our things we collected fat versus calories. So there was a menu item that had 9 grams of fat and had 260 calories. Another item had 13 grams of fat and 320 calories. Another one had 21 grams of fat with 420 calories, 300, 530, 31, 560, 34, and 590. So this is actual data from a menu from a restaurant. So a few things you have to kind of think about. You have to determine which one's going to be your X value. Well, generally, you'll do your X and Y values just like that. Okay. So then we're going to take that data and we're going to go to the next screen. So I have written down a separate sheet of paper, but basically what it says, determine and label your X and your Y axis. Okay, we'll take care of that in a minute. Count off the units you need your X and Y axis to be in. Plot your data points. Draw a line of best fit. Be sure the line goes past the data both ways, and I'll talk about that when we get there. Find your slope in linear equation. Put your linear equation as y equals mx plus b. Okay, so we won't keep it as point slope. We'll actually solve it from there. So we have our x and our y axis. So we're going to call the x-axis fat. And then y-axis we'll call as calories. Okay, and then we want to count it off. Now, from our data on our x-axis, it basically went from 9 to 34. So we want to space it out. So maybe we can count by fives. So I went a little bit beyond our data, but that's okay. Okay, and then our y-axis went from like 260 to 590. So a lot of people want to jump right on and say, hey, let's count by hundreds. That might be a little too much. I'd say maybe we can count by 50s. Oh, looks like I'm going to kind of 550 is way up here. Okay. Then I guess we could expand it a little bit. Up here, way up here, we're at 600. Okay, so our data was 9 and 260. So 9's about here. And we're going to go straight up to 260, and we're going to estimate as best we can. And then we have 13 at 320. So 13 is about here, so we're going to go up to 320. And then we're going to go 21 and 420. 30 and 530. 31 and 560. And 34 up to 590. So that's way up here. Okay, so I have a straight edge I'm going to use, and maybe we'll make it an aqua color. So we're going to try and draw in a line of best fit, or best we can. I'm going to continue the line in both directions. So this continues this way, this continues this way. Okay, so that looks like a good line of best fit. So then we want to find two of our data points that are they're far apart, but as close to the line as possible. So this one here seems to be a good point, and this one here seems to be a good point as well. So the first one would probably be the line, or the point 13, 320, which is at that point. And then this point right here looks like 2, 3, 4, 4 pieces of data. 1, 2, 3, 4. So it looks like 30, 530. Okay. Now, so that's just what we did. We had to pick. You don't want to pick 2 points that are right next to each other. You want to pick them out far enough apart, but they're still as close to the line as possible. So I think those are both pretty good for ours. You might have chosen 2 other points, but as long as they're far apart, you should have a pretty close answer to mine. So first thing we want to do is I'm going to label it. So I'll call that x1, y1, x2, y2. And for sake of time, I'm going to use a calculator so I don't struggle around with getting the answers in. So first thing I want to do is I want to find the slope. So remember our slope equation is this. So I'm going to go 320 minus 530 and 13 minus 30. So 320 subtract 530 is negative 210. And then 13 minus 30 is negative 17. So we get negative over negative, so it's positive. So we have a positive slope. So we get 210 over 17. Now sometimes when you're dealing with a line of best fit, sometimes it's best to make this a decimal. I know we haven't really talked about that much, but you just take the top divided by the bottom, and that comes out roughly to 12.35. So we have a slope of 12.35, okay? So then I'm going to go ahead and use my point slope equation. And I'm going to use, this is my x1, y1. I could use the other one. It's going to come out the same. So I'm going to get y minus 530 equals 12.35 x minus 30. And at this point, I would distribute over the parentheses. Now, you really want to have a calculator when you're doing this because, you know, you don't want to deal with multiplying these big numbers together, but the 12.35 times x is fine. But then 30 times 12.35 comes out to, and it's negative 370.5. And then what you want to do is you want to get y by itself, so you're going to add 530 to both sides. And notice I'm not adding it to the other x value. I'm adding, so those cancel. I want to have like terms. So I'm going to come up with positive 159.5. So this is my line of best fit equation. Okay, so let me write that down so I can use it on the next screen. Okay, so what is your equation for the line of best fit? Well, we just had it, we just wrote it, so I'm going to rewrite it. So what does the slope mean in the context of this problem? Well, right now our slope is 12.35, and usually you're not used to a decimal, but this is basically over 1, okay? So remember, the slope is the change in the y direction over the change in the x direction. So the y direction, we're talking about calories. In the x direction, we're talking about fat. Okay? So this means, in the context of our problem, for every 12.35 calories, we add 1 gram of fat. Okay? Let's see. Now, our line of best fit, where does it cross the x-axis? Well, if we go back to our original graph, it's going to cross the x-axis way back here in the negative region. So that's kind of funny because that would mean like we would have negative calories or negative fat with calories. Well, we're not going to have negative fat in something. But think about where it crosses the y-axis. The y-axis crossings right here. Okay? So let's think about what this means on our line of best fit. Okay, we can't really determine exactly what it looks like. It could be 160, maybe 165, somewhere in there. So we're just going to approximate it. We're going to say it's about 165. Okay? And that, again, that's in the y direction, so that's calories. So that means that 0 fat, whatever you're eating at this restaurant will still have 165 calories in it. Okay, now, that might not be the exact value. So let's think about what our equation is. It was this equation. Okay, and if I were to take this 0, because 0 is where it crosses the y-axis, if I take that 0 and I plug it in for x right there, so that's going to cancel. So I get 159.5. So that's probably a lot more accurate. This was just a guess. Okay, but this is the actual. That's what our equation shows. Okay, so again, that means that if we eat a 0-calorie meal, we would have 159.5, or if we had a meal with 0 fat, I'm sorry, I misspoke, it would be 159.5 calories. Okay. So when you extrapolation of data is, remember our data was like this. Okay, so if I wanted to pick something way down here or way out here, that means we're picking outside of our data. Again, if I had my data that was all plotted, if I wanted to do interpolation, that would mean I'm picking values in here. So that's inside our data. It should be data. Okay, so using our equation to predict. Okay, so let's say we have y equals 12.35x plus 159.5. If I wanted to pick something outside, or when I was given an x value, let's say we said, we know that we have an x value. Let's say we want to pick 10 fat. Okay, so that's an x value. So we want to solve a y value. So I'm going to plug 10 into the equation. So I'm going to get y equals 12.35 times 10, because it was an x value, plus 159.5. And again, you want to use your calculator for this, okay? So 12.35 times 10 plus 159.5. So that's going to give me an answer of 283. So that means if I ate a meal at this restaurant, if we ate a meal at this restaurant and it wasn't on the menu, but they realized there was 10 grams of fat in it, it means we'd have 283 calories for a meal. But what about if we had the y value given? So let's pick a value that's not part of our data. Let's say we eat a meal at the restaurant that has 500 calories in it. So that's a y value, right? So you're going to take that y value and you're going to plug it in right here. So rather than y equals, it's going to be 500 equals. We're just going to solve this as a two-step equation like we've been doing all along. Yeah, it's a little bit bigger, but we have to realize that we can go ahead and do this. And again, if we have a calculator, we shouldn't fear the numbers too much. So this comes out to 340.5. Then I get 12.35x. How am I going to get x by itself? I'm going to divide each side by 12.35. So those cancel. So that's going to say x equals, and I'm going to go 340 on my calculator, 340.5 divided by 12.35. And that's going to come out to roughly 27.6. So that means that if I ate a meal at this restaurant, if I had a 500-calorie meal, I would have 27.6 grams of fat in our meal. Okay, so this takes some practice to do, and it's just kind of exploring data. I know a lot of times you do this in your science class. So the homework is going to be page 97, 98, 99, and last page too, and 100. So it's a lot of pages, but I just want you to do the work on page 97. So page 97, problems 1 through 9 are the problems I'd like you to do. Okay, so it's just the very first page. It's what's on page 97. 98, 99, and 100, we're not going to worry about those, okay? All right, my friends, have a great day. Take care of one another. Bye-bye.